Hello everyone, this is Yusuf Yusri, and I will give you today a lecture about best practices and state-of-the-art techniques that you may use or it's recommended to use when you are training your neural network. These are the objectives and the outlines that we will go through in this lecture, and you should know how to use in class. I'll teach you how to do this. Dropout, patch, normalization, early stopping, learning rate, scheduling, grading, clipping, optimizers, data augmentation, and the using of pre-trained layers. All of these, as I said, most of them we will apply in Keras. So before we start in the lecture, let's build our basic Python script that we will build upon for each of these techniques. Okay, this is an empty Python script. First, let's import our dataset from Keras the datasets. It has a lot of datasets that you may want to experiment. The dataset that we will use is CIFAR10. CIFAR10 is a dataset for images for 10 objects, or for 10 classes. You may look to the internet for some more description for it. Then I will import the layers that we will use from Keras. First, a convolution 2D. Then I will use max pooling 2D. Also flatten layer and a dense layer. Yeah, so far this is like the layers that I will use. Maybe I will add more to the lecture. Okay, let's import our dataset. This is the training set. X train and Y train. Then X test and Y test. C4.load data. This is it. So let's make a function to create our model. Let's make it make model. I need to define a specific class for models. They call a sequential model from class. Let's add a convolutional layer. The first parameter that we want to add here is the number of filters. Let's make it 96. And then kernel size. Let's make it 5 by 5. You need, if it's like the width at the same as the height, so you need only specify one integer, which is 5. Let's leave the strides like 1 by 1 SDR. Then we need, like, one of the most important things that we want to add is the input shape. Input shape is basically the input that we will be fed to the network. You need only to specify this parameter in the first layer. It will be inferred for the next layers. You don't need to specify it for the next layers. So what is the input shape for the images? Let's print it. Okay, it's 32 by 32 by 3. So let's specify it. Yeah, one more parameter that we want to specify is the activation. If you left it by default, it will be linear activation, which is not useful, as we want to capture all the non-linear patterns in the dataset. So the one that is recommended to be used is the ReLU activation. Let's add max pooling layer. Pool sizes, let's make it 2 by 2. And strides, let's make it 1. If you left it by default, it will be 2. As the number of pooling size. Yeah. Then let's add another convolution layer, same as this. Let's make the number of filters in 128, and the kernel size, let's make it 3 by 3. You don't need to specify the shape. And let's leave the activation ReLU as it is. Another max pooling. Let's leave the stride as by default to be 2 by 2. I think that's it for the convolutional part. Let's add the flattening layer. as the output of the convolutional layers, and the max pooling is not 2D. So we need to make it like 2D tensor so that it can be fed to the dense layers and the fully connected layers. And we do this by the flattened layer. Then let's add 2 dense layers. Let's make the number of units 512. And the activation is Relo, same. And another one. And the output layer. Output layer should have 10 units, and it should take the softmax activation to produce some soft predictions for us, which is the probabilities. I think that's it for the model. Let's return the object, and let's create an object for us. Make model. Let's compile our model. The compile function take some parameters that we need to specify. First is optimizer. I'm sure, like maybe by now you may know what is SGD, stochastic gradient descent. So I will import it from class. Let's specify the linear rate as 1e minus 4, as the default is 0.01, which is I think it's very big for this problem. Then the matrix. Before the matrix, there is the loss, which is more important than the matrix. As it's like a classification problem, we should use a sparse categorical. Yeah, categorical cross entropy. Okay. Yeah. And then the matrix. The matrix is the list of basically of metrics that you want to be reported during the training process. Here, I want to report also the accuracy in the training. It will not affect the training at all, but just to be reported. That's it for the compile function. Then let's fit the model to our data. X, the training, then Y, just Y test, or sorry, Y train also, yeah. And yeah, validation, the validation split. Validation split is a percentage from the training set so that we can use as a validation data for us. A validation data is some data set, specific data set. It has a specific use, which is to tune the hyperparameter. It has also more usages, like we will discuss also in this lecture, like the earliest topic. So let's take it 15% of the training set. Then I want to specify like the epochs. Let's make it 30. And verbose, I prefer the 2. There's 0, which is like there is no verbose at all. And there is 1, which is like some frequent verbose. I don't like it. I like the verbose of 2. You may use 1 or 2. And the batch size. Let's use 128. Then let's print the evaluation of the model on that testing set so that we can get the true accuracy or the true risk of this model. Let's try to run to check if everything is going okay. Okay, I think it's working. We got some like loss, some accuracy, initial accuracy. And this is the second epoch. Okay, it's going okay. This is the training accuracy. This is the validation accuracy. So that's it pretty much. Let's start in the lecture, but first let's commit this change.